building Whirlwind was not like it was a thing that you sat down and designed and built, and then there it was, and you might have to maintain it, but it was a thing which grew over a period of years. It grew in our understandings of it and how to build a thing like that, which would be high reliability. And so, in parallel with the construction of the machine itself, a study of how to build software, and considerations of various applications. Whirlwind was originally intended to be the central machine for a simulator. The idea of a simulator sort of vanished over that period of time, largely because we saw that there were many other applications which are much broader and more important than the simulator one. And we looked at various things. We looked at use for air traffic control. We looked at use for communications networks. We looked at the use of a computer for air defense. This was all back in the mid-'70s. And that sort of caused a steady advance and broadening of our attitude toward the computer and what it would do and how it should be built. Now, among the things that were the major thing that was missing in the computer business in the early days, and for a long time, was the matter of memory. Early computers were built on things that came out of radar. Mercury delay lines were used by some of the early computers, which had the difficulty that they had long access times. If you wanted a word, you'd have to wait for it to come by. And electrostatic tubes, storage tubes of one sort and another. And we originally started building Whirlwind with storage tubes, special tubes that we made ourselves. The real, I think, important step, the most important early step in computers, was J. Forrester's invention of the core memory. Whirlwind, as I say, was originally built with electrostatic tubes. And these were hard to build, they were expensive, they did not last very long. So we had to develop the core memory, which meant making sure we had the right materials and devised ways for threading the cores and testing them and so on. And that was all done at MIT in what had become the Digital Computer Laboratory. And by 1953, we were able to make a core memory which had a profound effect on Whirlwind, and I think a profound effect on the whole business. I used to say that the effect of putting the core memory, we built, in order to do the core memory work, we built a special computer called the memory test computer, whose only purpose was, our first only purpose was to test core memories. We found in Whirlwind that when it came to testing parts of Whirlwind, that the computer itself was the best test instrument. And so we built a special machine for that purpose. And we built a core stack and tested it, and it worked. And we carefully built one that would fit into Whirlwind. We took it over and put it in Whirlwind. And the result of that was to triple the operating speed of Whirlwind. I think it changed the transfer rate between the in and out systems and Whirlwind itself in the central computer by a factor of 5 or 6. It reduced the maintenance time on the memory part of the computer from 4 hours a day to 4 hours a week. and changed the error rate from about one mistake every few hours to one error every few weeks. So this was a profound change. I think that's the major thing that happened, but we also built were the first people to put displays on a computer and to have man-machine interfaces. And there are lots of things that were done first. My feeling has always been that although we invented a lot of interesting things, we were the first people that ever came across the problems. So we naturally were the first people to solve them.